Welcome to the session, everyone, on water body for surface and groundwater. This is the third webinar on the occasion of World Water Week 2022, which is observed around this time of the year. I am Swapnil Poddar from Ira Sustainable Water Solutions. Today's agenda would be broken down into 5 points. First is context of our topic in regards to the World Water Week. Next would be trends on a global scale, then coming down to India's level and coming down to where we are right now in Maharashtra. Third would be an action plan, followed by practical case studies which are implemented on ground, and way forward on how we can make an impact on a bigger scale. World Water Week is a leading conference on global water issues held every year since the year 1991. Participants from varied backgrounds like scientists, researchers, economists, social entrepreneurs, corporations, they come together to share and develop solutions for greatest water challenges across the globe. This year it is being held in Stockholm, Sweden, and we are touching upon one such problem with a tangible solution supported by a practical and a pragmatic case study. The theme this year is seeing the unseen. So seeing is something visual, which is surface water, and unseen is the groundwater. We will touch upon those both aspects. The theme helps us view water in new and fascinating ways, and it draws attention to the unseen water in aquifers and the soil. To start with trends and challenges. So here I've shared a photo. These are dinosaur tracks, and these are one of the longest dinosaur tracks in the world. They've been discovered at Texas at a national park, which is called as Dinosaur Park. This is a river in Texas which was hit by a severe drought. It's the worst drought recorded to date, where the water levels have receded deeper than ever before. And these dinosaur tracks have surfaced, which are over 100 million years old. So this is one indicator of the ongoing drought, and this is the current year, 2022. Next picture, this is Lake Mead, which is very well known for the Hoover Dam. The water levels there have receded to a record low, and this has made international headline that Lake Mead is drying up right before our eyes. Sunken boats, carcasses at the bottom, they are surfacing up. This is another picture of a famous tourist destination in France, which is known for its water body and the architectural beauty. This year, the tourists are literally walking the river. And this is a recent news from Maharashtra. A journalist is seen walking a dried up river. So drought does not look different in different parts of the world. So the challenge that we are trying to address today is drought. And drought is observed in almost all the continents as I speak in the current year 2022. Once water surplus states or nations, they had more water than what they need, they are facing this drought. And researchers have to say that the reasons are more of anthropogenic, which means they are man-made or influenced by humans. And that results into warmer climatic conditions, changing rainfall patterns, shorter spells of higher rainfall, excessive runoff of water. As we had looked at global drought vulnerability index in the last session, India is already leading the vulnerability index in red. And drought is already looming over all other countries, including all Indian states as well. Drought is more visible now and accepted as it is observed that open water streams, like we saw in the previous pictures, are drying up. But how does the surface water shrinking in some ways related to the groundwater situation? That is the invisible part. Well, there is one solution to this, and this is water bodies, which not only retain surface water, but also protect and preserve the groundwater. Let me show you how. So to introduce a concept of water body, what exactly is a water body? So water body in simple terms is any significant accumulation of water on the surface of Earth. That is called as a water body. And the term most often refers to oceans, seas, lakes, rivers, ponds. It also includes smaller pools of water, such as wetlands. To classify these on the basis of water holding capacity or the nature of the body, they are briefly divided as below. Biggest being oceans, next being inland bodies landlocked or static bodies. Third, dynamic water bodies, which are in motion, which get revived as the water cycle revives itself. Next is frozen or the glaciers, water body trapped in glaciers. And lastly, could be others, which consists of lagoons, bays, channels, marshy lands. Now, on the basis of how these water bodies are formed, there are two basic types. First are natural water bodies, which are formed by geogenic causes, which are environmental occurrences. And next are artificial or man-made water bodies. How are the natural ones formed? So natural ones are formed by typically three reasons. The first being earthquakes or movement in the tectonic plates. Second is meteor showers where craters are formed. And third is natural contours or erosion which happens over centuries. Let me illustrate one which is formed with an earthquake. So this is one of the most prominent water bodies formed by an earthquake. This is a picturesque lake which is known as Atabad in Pakistan. This is a crater formed by meteor showers and which may take centuries for the land to settle, saturate, and then start to hold water. Now, any guess where this place is? Well, it's Lonar Lake in Maharashtra. It is one of the largest water bodies in India formed due to a meteoric crater. And this has been holding water for centuries together. And this has also attracted biodiversity, forest lands in and around the crater. So let's look at a practical case study. Can we make a water body of this scale or something like this? Well, fortunately, the answer is yes. Here I will share our approach, research, and practical implementation on ground of how a water body takes shape. So it starts with the year 2016-17, where we were fortunate enough, we got a chance and we conceptualized a water body for sustainable use of water in a remote area. We are a part of Research and Innovation Action Project conceptualized by the European Union. There, we had technology partners from India and Europe. We designed the water body by integrating different technologies and developing our own in the process. So there are typically three crucial factors which are important while designing a water body. The first being aerial. So aerial survey helps us understand what exactly that land is like, what the topography is like. Second is surface level survey. So we understand how the terrain is, will it facilitate accumulation of water. Third is subsurface study. So that is we understand what is beneath the surface. So when we integrate these three factors, these three studies, that's where we get to understand if we can make a water body there. It looks somewhat like this. The first being aerial survey, second surface level study, and third is subsurface study. And this is case study of an industry which is located in a critical zone. Annual rainfall here is around 200 to 300 mm, which is a drought prone area. The terrain is very much a flat table and hard strata right from the initial surface. You would notice that there is very less vegetation in the surrounding premises. This land has a history of not retaining water. After aerial analysis and surface level analysis, the observation from the study found out that there was one of the area in the facility which could be utilized to channelize the water with minimal infrastructural changes. Secondly, the substrata or the geology was found to be worthy of recharging the ground and thereby retain surface water. After these two initial studies, this was the photograph of the site before starting the work. This was during peak summers, and we studied that the area available that we had at hand was around 4,000 square meters, which was sufficient to tap the water volume as per our calculations. This was the first step where we started. A short clip of how we cleared that area. We deepened to create a natural gradient for the water to get channelized at this location. Post that, we created recharge wells where once the water follows the gradient, it is accumulated at this location. It facilitates the recharge of runoff water into deeper stratas naturally. And if you notice, if you notice the base of the water body, it is not concretized or lined with plastic sheets. It is natural strata maintained as is. We built infrastructure to tap the water to augment the groundwater levels naturally. That is the invisible part. And after years of monsoon showers, the hydrology started to retain water, though it wasn't visible on the surface like a water body. Over the next few years, the water level started to show a visible result. This was after the ground was saturated, the water started to retain on the surface. In the next photo, you can see on the right, the groundwater is visible through that very recharge channel. This is the evidence that the water levels have started to rise. As a part of monitoring and data gathering, we even monitored the levels of the groundwater rising year on year during different months. And to monitor it real time, we installed an instrument which could measure the groundwater level rising up real time. And these levels were assessed periodically. The instrument looks somewhat like this. And after a few years, when the water levels had reached a level where the surface could retain water, the water body looked like this. So it was a long 4-5 years journey compressed into a few slides. And this is the end result after years. Let me share a short clip of how this changed over the past few years. The results vary from site to site, but this will give you a rough idea of how a water body takes shape. As I said, the area was approximately 4,000 square meters. It could hold 2,500 cubic meters of water on the surface after recharging the ground by over 5,000 cubic meters of water. This is where we started to see water visually. This is a clip of the groundwater, which you see, which has augmented after a couple of years. And this was in 2019. Water started to retain naturally. And still, if you notice the strata behind, there is barely any vegetation or there is not much water retention. And this was in 2020. So this is one of the case studies which showed us very positive results. Likewise, we could implement such a project in different locations in the years to come. We've been monitoring the results as they vary from place to place. So this is another place where we could create a water body, and there we had a larger area to cover. We could conserve more water in a smaller footprint. The area of the clip that I'm about to show you was approximately 1,500 square meters, but it could hold 45 lakh liters, that is 4,500 cubic meters of water. This was while the work was in progress. We had installed a very comprehensive aeration system which purifies the water naturally. This was after it started to rain. Initially, the water had a particular color, but over the years, now the water quality is this. This was another case study which corroborated that our approach, our technique can be replicated and it can retain water. And we even monitor the water quality levels as and when the seasons change. So the good part is that we have measurable outcomes now, considering the data that we have gathered in the past 5 years. So to summarize that, we have seen 60% rise in groundwater table, 45% enhancement in the quality of water, almost zero or say 85% reduction in runoff and downstream flooding. That is, the water is not allowed to flow out of any premise. Last is carbon sequestration. So the amount of carbon that is sequestrated, that is also being monitored. We are in the process of putting in instruments which can measure these. Some of the corporates, they already have these kind of instruments where they are measuring the carbon sequestration. So this approach and technique which we have developed, how it is different? It is a sustainable method which is built out of experiments, failures and successes in the past few years. It needs a certain engineering and technical expertise where it does not involve any kind of concretization of the land. The solution development happens by a cross-functional team of experts where we consider structural consultants, their opinions, hydrological experts, we take into account engineers and designers, where we integrate all of these together and then a water body takes shape. And the measurable outcomes, as I shared, water conservation volume year on year, it can be measured. If it is done within the fence, the water can be used for process, landscape, domestic use. If the premise is small enough, it can be done outside the fence. Then the visible part, surface water, you start to see water being retained at that place. It even retains throughout the year, ensuring that groundwater is protected. This can remediate a land, that is a degraded land or a parched land can be afforested. We can have afforestation where we create a water body. And lastly, it can attract biodiversity. We have also seen migratory birds coming to these water bodies. And very well, these making a water body fits into industrial initiatives as well, like being water neutral or being water positive. And now there is a new regulation for top 1,000 listed organizations that, as a part of BRSR, business responsibility and sustainability reporting, they need to have certain measures where they are conserving more than what they consume. So this pretty much fits all of those initiatives in one go. As a way forward, I'm glad to share that now this has been taken very seriously by the central ministry. The central ministry, or the Jal Jeevan Shakti ministry, has launched Mission Amrit Sarovar, where they are planning to create or rejuvenate, revive 75 water bodies in every Jilla. That is being followed even at the corporation level. Even Pune Municipal Corporation is taking up such initiatives to revive dried up water bodies. The Mission Amrit Sarovar, they are trying to create water bodies which are spread across 1 acre, or roughly 4,000 square meters. But it's a good thing that water body can be made in an area as small as 500 square meters and can easily hold 10 lakh liters of water. The picture that you see is one of the industries which had a very small footprint. The total area must be around 6 to 7 acres. Yet they are able to create a water body of this scale, which is helping revive groundwater at the same time. Once that is the ground is saturated, it can hold water throughout the year. However, the rate of retention of water, it varies largely on different factors. Like I had said, it could be the catchment area, the volume of water, geology, climatic conditions, and so on. This is a concept which is at a design stage. This is another industrial area where they have this area was mined earlier, around 30 years back. This was mined. Now this area remains unused. Even filling that up with landfill, it is quite an expensive proposition. So what we are trying to do is we can convert this abandoned area into a water body like this. So converting an abandoned mine site, we can convert a degraded area, or which is otherwise unusable, into a water body. Uh, the amount of water that can be conserved within this premise, that particular industry will not have to buy a drop of water from outside for the entire year. So this will be a self-sustainable kind of a cycle where the water body gets replenished during monsoons and it is used throughout the year. So the process of making water bodies, the way we do it, it involves a ground up approach where water which otherwise would run off starts to saturate the deeper strata, and that's where the strata starts to retain water on the surface. On this note, let me share a fact. California is trying to secure such water bodies to move water underground to fight droughts in the future. They are trying to protect their surface water by moving it underground. So this is the connection between surface water, which is the visible part of it, and groundwater, which is the unseen part. So these are primary points for anyone to consider a water body. And in our side of the assessment, we consider other dimensions. So the basic points are, if you have an open land area of 500 square meters, if you have a catchment area where there is roof runoff or surface runoff or hill runoff, and if you have a natural strata which is not altered without any landfill, it is worthy of, it is, we can make or pretty much make a water body in that premise. And later we consider other dimensions like developing a gradient, identifying the recharge zones, monitoring results over the years to develop a viable solution. So to summarize today's session, first we talked about the context of World Water Week. Secondly, the theme, seeing the unseen, and we addressed drought as a challenge. Third, how water body could be a solution, and the types of water bodies, classification of water bodies, classification on the basis of formation of water bodies, and how water bodies are made. Then we looked at a practical case study, which is also a success story, so a success story with measurable outcomes, and the way forward. So I thank all of you for being patient listeners. My 20 minutes are up. And on a closing note, I would like to share my vision, which is to make India water secure.